hello grade 11s that can't make it to the Friday lesson or want a bit of clarification. Okay, so heights and distances in one plane. We're doing two examples from the textbook, and the first one, you'll see why I've picked out this as one of the examples to do. We've got a few things going on. We need to figure out what's happening in these types of questions. We're just using the knowledge we've built up so far to solve problems. From a point on a building, on top of a building, let's do this, we have all the space. So, top of a building, we're on this building and we're looking across at this other building. See, already it feels confusing because you're on this building looking down, but I'm going to tell you, we're sitting over there, there you are. Great artistic skills, right? So, we're looking from there, and the angle of elevation. Okay, so here's something that we may have half looked at. Angle of elevation to the top of a nearby tower is 25 degrees. So angle of elevation, looking up. So that angle, if we drew it in compared to looking straight out, that is 25 degrees. Then we're also told that the angle of depression, that means looking down, is 20 degrees. So just reconfirming those ideas of elevation and depression. So if we're looking down, then we're looking, compared to looking across, then we've got 20 degrees. Now these conveniently form these nice shapes that we've worked with over the years called triangles. If the height of the tower is 30 meters, remember the tower is the one on the right hand side. So if that tower, let's go back to red, says this whole thing here is 30 meters, how far is the tower from the observer? So how far is this distance here? So just working through it quite quickly with you to go, well, we're looking for this distance here. Well, that distance, if we need it, is the same as the distance on the bottom. So this is the type of thing with these types of questions, are just figuring out what's being said, turning it into a bit of a diagram. And when you look at the past tests, you'll see that quite often you're given the diagram. It's not about drawing the diagram, but kind of making sense of what's there. And maybe you're told this is D, but this isn't D. You're not told that. Well, you can see that they must be the same. Right, so we've got distance, we've got two triangles. It looks like we hardly know anything about our triangles. We know one side and we know an angle. Well, we can't get too far with that. In everything we've done so far, we've known at least two things, normally three things about our triangle. In fact, we must know three things. So we either got side, angle, side, side, something that's going on. But we do know this whole distance is 30. So I know it's staring at us in the face to say, well, we do have some other piece of information, and that is if this whole thing's 30, let's let this side of our triangle be x, then this side down here, this side here, is 30 minus x. So if you add them together, you get 30. Now you wouldn't notice that you're not given that bit of information. You're not told, let this equal x, although maybe a question will help you along there. So let's pause, take stock. I've written everything that's there into our diagram. We've added a bit of extra information to go, let's let that equal x. Then we got that 30 minus x. Now the key bit, apart from elevation and depression, of why I picked out this question, is because look at these triangles. They're very special triangles. We started this section and we said, cool, we're going to do sine rule, cos rule, area rule. And what's exciting about them is that we don't need right angle triangles. And here we do have right angle triangles. There's a right angle triangle. There's a right angle triangle. That's right angled if we needed. That would be right angled. We've got a rectangle. So actually, let's have a look at this. 25 degrees. Look in this top triangle. You've got a right angle triangle, so you've got your opposite and your adjacent. So I'm always in the Edpuzzle mindset thinking, pause, ask the question now. But so if we've got opposite and adjacent, which trig ratio are we using in a right angle triangle? we're just using tan. So tan of 25 degrees in this top triangle is opposite, which is x, over adjacent, which is d. Okay, now in this bottom triangle, we've got 20 degrees, right angle triangle, opposite and adjacent. So tan of 20 degrees equals opposite over adjacent. So opposite over, that's a great line, over adjacent. Okay, there we go. Two equations and two unknowns, x and d. I think where else have you seen the case where you've got two equations and two things you do not know? Simultaneous equations. Think when you had like y equals x minus 3, and you've got another equation that's got like 1 over x, y equals 1 over x plus 4. Oh, and then you substitute this bit over here, and then you make them equal to each other. Remember, simultaneous equations where two graphs intersect. Same idea here. Now, I'm not sure you'd solve it. One way is make them both like d equals something, or x equals something, then make them equal to each other. Like here, y equals, so they're equal to each other. Or perhaps you just make x the subject of the formula and then substitute that into the other equation. So let's see what I mean by that. Multiply both sides by d. D tan 25 equals x. Okay, so if d tan 25 equals x, and let's get rid of this fraction here. So let's multiply both sides here and go d tan 20 equals 30 minus x. Well, we can, this is x, that's x, so we can put that in place of this x, and we're going to form one equation with one variable. So we're going to say d tan 25 is x, so let's substitute it into this equation. Sometimes people write, this is equation 1, this is equation 2, we're subbing 1 into, that's, I don't know if that was in the way, into 2. Not really necessary because we can see it. So we got d tan 20, that's that part, equals 30 minus, and instead of writing x, we can write d tan 25. One equation, one variable. What we're trying to find is d. We're trying to find the distance. So there we go. Solve your equation and you're good to go. So I'm just going to quickly hit pause, solve it, but I'm going to solve it here in the background too. D tan 20 plus. Gotten quite used to having the music while doing this. Kind of feels weird not to have it. Okay, d common factor, tan 20 plus tan 25 equals 30. Divide both sides by that whole thing. Tan 20 plus, I'm going to write it, scribble it because it's quite clear what we're doing. That's going to do it on one side, do it on the other. Doesn't need to be in brackets, but I'm going to put it in brackets because then it's useful. D equals calculator fraction 30 over tan 20 plus, ooh, should really get quick on the calculator, tan 25, and I got 36,13 whatever. Let's go to no decimal places. Assume everything was in meters. That seems to make sense, but just double check your unit. 36 meters. Does that seem to make sense? Well, it's hard to tell really. I can't see from the scale myself. 20 degrees, does 30 make sense? I guess if it was like 3,000, that would seem weird. Or for like 0.1, that would seem weird. Anyway, 36 meters. So there's how we might solve something like that. hopefully that's useful and everything's clear now.